Welcome everyone to your virtual academic orientation tour. My name is Nikki and I'll be your virtual tour guide today. I graduated from the Aerospace Engineering program here at Carleton a few years ago. I now work for the Faculty of Engineering and Design's outreach team. In this tour, we'll be looking at some important spaces on campus, including some labs you can expect to see as you progress through your degree. Our tour begins at the Minto Center. From the main atrium, we will be heading down into a chemistry lab that is primarily used by environmental engineering students. Next, we'll be visiting the large testing facility on the main floor and the Engineering Academic Support Office. On the 5th floor, we will be viewing the Elsie McGill Learning Center. And finally, on the 6th floor, we'll be visiting the Biomedical Engineering Lab. We're now in front of the Minto Case building. This is part of the main engineering building on campus and is connected to the McKinsey building, which you'll see later on. Let's head inside. In the main lobby area, if you look to your right, you can see the entrance to one of our largest lecture rooms, Bell Theatre. Remember this location, as a lot of first-year students always struggle to find this theatre. We'll now be moving downstairs to our environmental engineering lab. We're now in the basement of the Minto building. This lab is essentially a chemistry lab for environmental engineering students to understand the chemical, biological, and physical processes involved in cleaning air, water, and soil. Students will take river water and separate its contaminants using chemical physical processes, or treatment using UV light. Wastewater treatment is done by using microorganisms to break down the contaminants in the wastewater. The materials that settle out form a sludge that can be degraded anaerobically to produce methane and energy. Air quality is measured and analyzed using an air sample from the roof of this building. Fourth-year projects include designing systems to clean air and water, cleaning up contaminated sites, gas stations, LeBreton Flats, evaluating waste management alternatives and waste to energy, designing systems to reduce greenhouse gases, and improving air quality and conserving water. Let's head upstairs. We're back on the main floor. This is the John Adelane Lab. This lab is used by 2nd, 3rd, and 4th year architectural conservation and sustainability engineering students, environmental engineering students, and civil engineering students. The test facility is 11 meters high and has 3,000 square feet of floor space. If you look up, you'll see a crane used to move heavy equipment around the room. This room is also equipped with a strong floor that is 1 meter thick. If you look down, you'll see circular discs that can be removed from the floor. There are approximately 600 holes in the floor to allow us to test different structures. Test beams can be secured to the floor through these openings. The foundation of this area is also separate from the rest of the building around us, so test vibrations do not impact the structure or disturb people working. MTS loading machines can perform compression and elongation analysis to samples rather than an entire structure at variable speeds, as stresses produce different results at different speeds. Tensile compressive and cyclic load testing is done using hydraulics wired to an Ethernet analysis, which can simulate year-long experiments in shorter times. Students will also have the opportunity to learn how to use surveying equipment and will make their own concrete beams to be used for testing shear strength.